Hello guys, good afternoon to all. My voice is clear to all. I'm still launching the technical poll. Okay, sorry. Let me check whether my voice is clear or not.
Hello, hello everyone. Hello everyone. Let's check whether let's wait for 2 minutes and like wait for the any participants that might want to come and join. So I'll be sharing my screen now. Let's begin the session. Okay, so last session we did vectors. Last session we did vectors lesson 1. First session has been done. Now we will be doing the second session of vectors. And first of all, let's check. So and for today's session is that we will be doing scalar triple product. I know this is a new term, but let's see what it is. Properties of scalar triple product, vector triple product, and application of vectors in geometry. Okay, so let's start with scalar triple product and let's see what it is. Before that, question related to previous session, and let's see if we remember. So the question is, if the force represented by 3 j cap plus 2 k cap is acting through the point 5 I cap plus 4 j cap minus 3 k cap, then its moment about the point 1 comma 3 comma 1 is. So here we know that the hint is given as calculated as r bar cross f bar. So what is the r bar? R bar is the vector. It is acting through this point and we have to find the moment about this point, right? So r bar is this minus this. Let's see here. So here we have force. P is given as 5 comma 4 comma minus 3. So see, this is P, this is P, and Q is our O is our point. Like if this was our space, 3D space. So here there is some point P, here there is point O which is given to us. We have to find the moment about it is acting through this force. The force is acting through this point. We have to find the moment about this point. So moment can be R bar cross F bar. So we calculated R bar first. R bar is OP bar, right? This OP bar is our R bar, which comes out to be 5 minus 1, 4 I cap, 4 minus 3, 1 j cap, minus 3 minus 1, minus 4 k cap. To calculate the moment, we have to do the cross product of R bar and F bar. We know how to do the cross product. We write the determinant for in determinant form: I cap, j cap, k cap, the first vector R bar and the fourth vector F bar, right? So this comes out to be 14 I cap minus 8 j cap plus 12 k cap. I hope this was easy to understand. Let's move ahead with the next question. So you have to solve this. First of all, let us understand that A, B, C, D lie on the same plane. Then A bar cross B bar cross of C bar cross D bar. What is this? So first of all, if A, B, C, D is lying on the same plane, so let me draw this diagram. So here there is somewhere A bar. Here there is B bar. Like this is A bar, this is B bar, this is C bar, and this is D bar, right? So what it is saying is, first we will calculate A bar cross B bar, right? What will the value A bar cross B bar give us? It will give us a vector which is perpendicular to the plane, right? So this I'm drawing a vector perpendicular to the plane represented by the dotted line, right? This is a vector perpendicular to the plane. This is A bar cross B bar. Now C bar cross D bar, let's call this A bar cross B bar. We know that A bar cross B bar is perpendicular to both A bar and B bar, right? Now this C bar and D bar, C bar cross D bar, let's make another dotted line, and this is like perpendicular vector, right? This is C bar cross D bar, right? Since these two are in the same plane, this C bar cross D bar is perpendicular to C bar and D bar. A bar cross B bar is perpendicular to A bar and B bar. So for A bar and B bar, sorry, we know that since A, B, C, D lie in the same plane, A bar cross B bar will be parallel to C bar cross D bar. So whatever it is, let's name this as P bar and let's name this as Q bar. So P bar and Q bar are parallel to each other. That means what? Angle between them is 0 degree. So what is the cross product of P bar cross Q bar? Will be mod of P bar mod of Q bar. Come out to be, see, mod of P bar Q bar is something, some known quantity, but sign of is 0, right? This is mod of Q bar mod of P bar into 0 into n cap. So this comes out to be 0, right? So the answer is 0. Sorry guys. Let's move on to the next question. Sorry. Let's move on to the next topic. Now our topic is scalar triple product. This is the beginning of the session. Now scalar triple product is defined as the dot product of a vector with cross product of two other vectors, right? Scalar triple product, see, there are two names, mixed product or box product. So whenever you write three vectors, A bar, B bar, C bar in a box, right? So this means as we are representing scalar triple product. So why this word scalar is dot of B bar cross C bar, right? So this dot product, see, B bar cross C bar is a vector, right? A bar cross A bar is a vector. So what we are doing here is we are doing dot product of two vectors. So this will give us scalar, right? So we have already seen that dot product results in a scalar quantity. Mathematically, the scalar triple product of three vectors is defined as this: A bar dot B bar cross C bar, and it is also represented as A bar B bar C bar in a box. Hence the name is box product. On expanding the dot and cross product, this evaluates to the determinant found by the components of A bar, B bar, and C bar. So we have to remember that scalar triple product can be found out by finding the determinant when the inputs of the determinant are components of A bar, B bar, and C bar, right? So this is how you can find the scalar triple product. Now let us see some application. So scalar triple product is used to calculate the volume of parallelepiped structure. So what is a parallelepiped structure? So parallelepiped structure is like, see, imagine a cube, okay, okay, imagine a cube, right? So this is our, okay, so this is our cube. Now this thing, keeping the base fixed, right? Keeping the base fixed, you are just tilting this straight line to a certain angle alpha, right? So this gets tilted, this gets tilted, and now this, so the faces become a little tilted, right? So this 3D structure, this 3D structure named as parallelopipe. Now you can see here, let's try to prove something. Here you can see that this is the base, this base B bar, adjacent side of the base is represented by B bar and C bar, and the angle between that B bar and C bar is given as theta, right? So in the above figure, area of base, we all know that area can be calculated by doing the cross product, right? B bar and C bar of the adjacent sides of a parallelogram. So this base is a parallelogram. These all structures are parallelogram, and these are like connected to make a 3D figure. So that is why the name parallelepiped comes. This should be O. Now area of the base is B bar cross C bar. Volume of the figure is height into area of the base. Now height is represented by A bar, right? So this is A bar. Height is represented by this line. You can see here, this is the height. So if we draw this line and try to find the height, this will come out to be A. This angle is given as alpha, so this will come out to be A cos alpha, right? So the height is A cos alpha, and we know the base, so this is given as A is this modulus of A, so this comes out to be A cos alpha into B bar cross C bar, right? So this angle, the resultant of B bar cross C bar is also perpendicular, right? The resultant of B bar cross C bar is also perpendicular to the base. So that is why this perpendicular and this perpendicular will make the same angle alpha. So hence the angle between A bar and B bar cross C bar is also given by alpha. So therefore this can be written as mod of A bar into B bar cross C bar cos alpha. So therefore this can also be, see, this is like this vector into another vector into angle between them, cos of angle between them. So this is like dot product, right? So hence you can write as A bar cross A bar dot B bar cross C bar. So this proves that the volume of parallelepiped is A bar dot B bar cross C bar. Now find the volume of parallel pipe where its edges are represented by the vectors this. So here simply what we have to do is we have to find, see, let's name this as A bar, let's name this as B bar, and let's name this as C bar. So what we have to do is we have to find the we have to find this scalar triple product like this. So we all know scalar triple product can be found out by finding the determinants of the components of all three vectors involved. So for A bar, the components are 1 1 0. For B bar it is 1 2 0. For C bar it is 1 1 pi, right? So if you try to calculate, this is 2 pi, this is 0 plus 0, this is also 0 minus, this is 0, this is 0, and minus pi comes. So this value comes out to be pi cubic units. So hence the volume of this parallelepiped is how much? Pi cubic units. See the solution. The volume is pi. Okay. Let's move ahead. Now, properties of scalar triple product. So obviously, like we know that A bar dot B bar cross C bar is scalar triple product. Now, what else? Like, what things we can say for sure about this particular scalar triple product? So let's check. The value of scalar triple product does not depend upon the position of dot and cross. So what this means is, like, if you write A bar, B bar, and C bar, you place the dot here, you place the cross here. You write A bar, B bar, and C bar. You place the cross here, you place the dot here. So this both will be equal. Okay. So hence the statement, right? So this can be written as, we know how to write this thing. This can be written as A bar cross B bar dot C bar, and that will be equals to A bar dot B bar cross C bar. So dot and cross are interchangeable. Dot and cross are interchangeable. Now, if A, B, C are cyclically permuted, the value of the scalar triple product remains the same. So what does this mean is, like, if you write this in a box, see, writing A, B, C, this is A bar, B bar, C bar. Now if you move this cyclically in a cyclic order, like, this was A, this was B, and this was C, and if you move this in a cyclic order like this, like this, like this, so if you do it again, then the values won't change. So this will be like, C comes to A, so A goes to B, and B goes to C, right? CAB, and this is also equals to, when again you do that permutation, and this gets B bar, C bar, and A bar, right? So why this is equals to this minus BAC is, see, A bar, B bar, C bar, we know that A bar, B bar, C bar is A bar dot B bar cross C bar, right? And if you write A bar dot, see, B bar cross C bar can be written as minus of C bar cross B bar, right? So that is why this also becomes minus ACB, like this. So see, you can see minus ACB. Similarly, if you prove this thing, you can also prove that this will be equals to this. Now in minus sign is taken outside, and then the cyclic permutation is done, which was done in the previous step. The scalar triple product of three vectors is 0 if any of the two are equal. Why? Like, the scalar triple product of the three vectors is 0 if any of the three are equal, right? Let me erase and get some space. Okay. Now in A bar, B bar, and C bar, let's say that any two vector is equal. Let's call it A bar equals to C bar, right? So what I'll write is A bar dot B bar cross A bar, right? So we all know that B bar cross A bar A bar will be perpendicular to A bar, right? Now any vector perpendicular to A bar, and when you do dot product with A bar, right? A bar and any vector perpendicular to A bar, this dot product will give you 0, right? So that is why the scalar triple product of three vectors is 0 if any two of them are equal. The scalar triple product of three vectors is 0 if two of them are parallel or collinear, right? So like what does this mean is like any two of them are in the same plane, right? So you can take any two of them in the same plane, and when these two are parallel, so if these two are parallel, then see I can like let's see in the first case we took A bar and C bar equal. In the second case, to prove this statement, let's take B bar equals to C bar, right? So when B bar, see, when B bar and C bar is equal, so B bar cross C bar will come out to be 0, right? B bar cross C bar will be 0. This term will be 0, and so yeah, so B bar and C bar is equal, then these two are 0. And when consider A bar is equals to C bar, right? Then what? A bar dot B bar cross C bar. Like A bar is parallel. A bar is parallel to C bar. Then what? When A bar is parallel to C bar, that means A bar and C bar are in the same plane, right? So B bar cross C bar will be perpendicular to A bar again. So that is why A bar and dot product of any vector perpendicular to A bar will again result in 0. So hence this point is also proven. Let's move ahead. If three vector A bar, B bar, C bar are coplanar, then A, B, C, this is 0. So this is the like extension of the previous 2 points. Okay, so this can be proved easily since two vectors are coplanar. So dot product of this vector and cross product of this vector will be perpendicular to this vector, right? So that is why it will come out to be 0. Now A, B, and C plus D, right? So this is what is written is, this means that A bar dot B bar cross C bar plus D bar, right? So this can be also written as A bar dot B bar cross C bar plus C bar cross, sorry, B bar cross D bar, right? Now you can write this as A bar dot B bar cross C bar plus A bar dot B bar cross D bar, since A bar sorry, dot product is distributive over addition. So hence this is ABC in box, this is ABD in box. Now scalar triple product generally represents the volume of the parallelopipe whose three coterminous edges are represented by ABC. So what do you mean by coterminous edges? So this point is the coterminal point where these all three edges are initiating. See, A bar, B bar, and C bar, right? So this point is meant by coterminal point. If A, B, C are non-coplanar, then is greater than 0 for right-handed system and ABC is less than 0 for left-handed system. So scalar triple product is positive when you do the right-handed system, like when you take the order in right-handed system, it is positive when you take the order for left-handed system. So I cap cross, so this point is I cap dot J cap cross K cap, right? So this means I cap cross J. Now J cap cross K cap, you can like I generally draw like this I J K. Other orientation of I J K is also possible. Now here you can see that J cap cross K cap, right? J cap cross K cap, J cap cross K cap. You can use the right hand sign. J cap cross right hand system. J cap cross K cap will result in the I cap direction, right? So J cap cross K cap will result as I cap itself. So I cap dot I cap will be equals to 1, right? Because the angle between them is 0 and mod of I cap and mod of I cap cos 0. So 1 into 1 into 1. So this comes out to be 1. So hence this formula. Now K What does this mean is K bar dot B bar cross C bar, right? So you know that this is a constant, you can take it out and write it down as K bar dot B bar cross C bar. So this becomes K times of A bar B bar C bar. A constant can be taken out where K is any scalar. Now, volume of tetrahedron with O as origin and the position vector A bar B bar C bar being ABC represented is given by. So, volume of tetrahedron can be found out, and volume formula is scalar triple product of those three co-terminal vectors divided by 6. 4 points with position vector A bar B bar C bar and D bar will be coplanar if. So you have to remember this property to find the condition of coplanarity. So whenever you have to do anything related to coplanarity, then you must use this condition. So what is this condition? D bar dot B bar cross C bar, D bar dot C bar cross A bar, D bar dot A bar cross B bar equals to ABC. We all know when two vectors are equal, then the scalar triple product is 0. And this point is just the extension of that formula which we did, right? You can write A bar as A1 into L plus A2 into M plus A3 into N. See, this L, M, N are non-coplanar vectors. Whenever you can represent a vector in terms of like this, then you can find the scalar triple product with this formula. This LMN is coming here. See this, the different LMN are the box product of LMN is done separately, and then this ABC, the components of ABC are kept in the determinant. Okay, so let's remember this. Now let x naught be the point of local maxima for f of x is this represented by C is this, then the value of A bar dot B bar at x equals to x naught, right? So like if someone, yeah, try to solve this question in a minute. Here, okay, so I guess this question is incomplete, guys. I'll write A bar is given as x I cap minus 2 j cap plus 3 k cap, and B bar is given as minus 2 I cap plus x j cap minus k cap. Okay, so these are A bar and B bar. Then we have to find the, we have to solve this question, right? So first of all, let's try to find out f of x, which is A bar dot B bar cross C bar, right? So this will come out to be like I'll take the determinant. A bar is x minus 2, 3 minus 2, B bar is minus 2, x minus 1, C bar is 7 minus 2 and plus x, right? So what this comes out to be is x cube minus 27 x plus 26, right? So this f of x comes out to be this. Now x naught is the point of local maxima, right? X naught is the point of local maxima. So first of all, to find the local maxima, we will differentiate this f dash x will come out to be 3x square minus 27, x square comes out to be 20, x square comes out to be 9. We will equate to 0. So x square comes out to be 9, x comes out to be plus minus 3. Now I will do the double differentiation. F double dash x will come out to be, f double dash x will be 3 to the 6x, right? So wherever for maxima, f double dash x should be negative. So 6x will be negative when x equals to minus 3. So x equals to minus 3 is the point of local maxima. Now a bar dot b bar. What is the value of a bar dot b bar? It is minus 2x, minus 2x minus 3. And b bar plus c bar is, b bar dot c bar is, b bar is minus 14 minus 2x minus x. And c bar dot a bar will be 7x minus 4 plus 3x, right? So this we have to find out, right? When x is equals to x naught, when x is equals to, when this is, we have to find out when x is equals to minus 3. Now this will come out to be, first of all, this is minus 4x minus 3 minus 14 minus 3x plus 7x plus 3x is 10x, 10x minus 4. So this is, what is the value? 10x minus 7x, this is 3x, and this is minus 3 minus 14 minus 4, this comes minus 21. So when you put minus 3, this comes out to be 3 into minus 3 minus 21, this is minus 30. So our answer is let's move on to the next question. See, sorry, this is plus 4, this is plus 4 here, this is plus 4, and this comes out to be minus 13. So this will be minus 22, guys. Okay, minus 22. See, the other things are similar, whatever we did are correct, right? Just make sure to not like make mistake in plus minus signs. Concept test. Now, a bar, b bar, c bar are non-coplanar vectors, and lambda is a real number. Then the vector this a bar plus 2b plus 3c, lambda b plus lambda c, and 2 are non-coplanar for what? So, can you understand this question? In this, we will have to use that property which we studied in the last. So let's call these all the vector as, let's call all the vector. See, this is what, this is like that property na, we've studied a1l plus a2m plus a3n, then b1l plus b2m plus b3n. So lmn are a bar, b bar, c bar, right, in this question. So what we will do here is, let's name this as alpha, let's name this as beta bar, let's name this as gamma bar. So alpha bar dot beta bar cross gamma bar, when this thing, we have to find out what this is, right? And lmn are non-coplanar vectors. So ABC are non-coplanar, so that is why our lmn will be replaced by ABC. So this will come out to be, see, coefficient of a bar is 1, 2, b bar is 2, c bar is 3. Here it is 0, lambda, and 4. Here it is 0, 0, 2 lambda minus 1, right? And here it will be a bar, b bar, c bar in the box product. So what this will come out to be, what this comes out to be is lambda times 2 lambda minus 1, other all the values will be 0. This will be a bar dot, this will be a bar, b bar, c bar, right? So what you can say from this will be 0 when lambda is 0 or lambda is half. So only at this point, when this thing is 0, then they are non-coplanar. Sorry, then they are coplanar. Whenever the vector is, whenever the scalar triple product is 0, then they are coplanar, right? And when it is not 0, then they are non-coplanar. So this is 0 for two values. So for all other values, it is non-coplanar. That is why the answer is all except two values of lambda. definition of vector triple product. So vector triple product is defined by, so in scalar triple product, it was a bar dot b bar cross c bar. For vector triple product, now this is changed to, this gets changed to a bar cross b bar cross c bar, right? So this is the only difference, that dot is replaced by a cross. Now here it is given, if we have three vectors a bar dot b bar, a bar b bar and c bar, then this and this are called triple vector triple products of a bar b bar and c bar. However, the values of each are different. We will now see what they are. So a bar cross, we know that b bar cross c bar is perpendicular. So see, when b bar cross c bar, whenever you do the cross product of two vectors, you get a perpendicular vector to both the vectors, right? So that is why it is perpendicular to b bar and c bar. Since a bar cross b bar cross c bar will be perpendicular to b bar cross c bar, it will lie in the plane of b bar cross c bar. That is why scalar triple product of three vectors, right? When you do the scalar triple product of these three vectors, this will its vector will lie in the plane of b bar cross c bar, because this b bar cross c bar is perpendicular to b bar, and this is also perpendicular to b bar cross c bar. So that is why it will lie in the same plane. Hence we can express a bar cross b bar cross c bar as the linear combination of vectors b bar c bar. Thus we write as a bar cross b bar cross c bar as lambda b bar plus mu c bar, right? Since it lies in the plane of b bar and c bar, that is why, since it lies in the plane of b bar and c bar, that is why we can write it as a linear combination of b bar and c bar. So this is the linear combination. This means linear combination lambda b bar plus mu c bar. So we have just multiplied the constant to b bar and multiplied the constant to c bar. By taking simple vectors such as I cap, j cap, k cap in the above equation, we can find the values of lambda and mu, right? So what are those lambda and mu, right? Whenever you do scalar triple product a bar cross b bar cross c bar, that lambda and mu, you have to remember this comes out to be a bar dot c bar into b bar minus a bar dot b bar into c bar. See, so b bar and c bar, see, whichever is there in the whichever is there in the cross product in the bracket, that you have to do in the linear combination, like you have to use those vectors. And the other thing is, for if you are using b bar, then the dot product will be for a bar and c bar. If you are using c bar, then the dot product will be of a bar and b bar. See, this b and c are getting interchanged, b and c are getting interchanged, so you can remember it like that. Now for a bar cross b bar cross c bar, so what we will do here is, so we know that a bar cross b bar cross c bar will be equals to minus of c bar c, will be equals to minus of c bar cross a bar cross b bar, right? So for this thing we have already found out, right? Let's forget this minus sign for now, and what will this be? This will be equals to c bar dot b bar, and taking the first vector minus c bar dot b bar taking the first vector, and minus c bar dot a bar taking the second vector here. So now you place the minus sign inside, so this will change to, so right, you can remember this thing like this also, or you can derive this. Generally try to remember one thing and derive the another, है ना? Remember this and derive this, right? Now, yeah, let a bar, b bar, c bar be three unit vectors, out of which, let a bar, b bar, c bar be three unit vectors, out of which b and c are non-parallel. If alpha and beta are the angles which vector a makes with vectors b bar and c bar, then a bar plus b bar is half times of b bar. Then the value of mod of alpha minus beta is equals to. So the information given to is b bar and c bar, the crucial information. See, first of all, it is all these vectors are unit vectors, so their modulus is equals to 1, and b bar and c bar are non-parallel, right? B bar and c bar are non-parallel because otherwise this will become 0, right, if they are parallel. So hence it is given. Now, if alpha and beta are the angles vector a bar, alpha and beta are the angles which vector a bar makes with vector b bar and c bar. Okay, so a bar and b bar angle is alpha, a bar and c bar angle is beta, right? Now we know that a bar cross b bar cross c bar. What is this? A bar cross b bar cross c bar is what? We have to keep b bar here, and we will do a bar dot c bar minus, we have to keep c bar here, we will do a bar dot b bar, right? So a bar dot b bar, a bar dot c bar will be what? A bar dot c bar, a bar dot c bar, a bar dot c bar will be mod of a mod of c into cos of beta minus, this will be mod of a mod of b into cos of this into b bar, this into c bar. So this will be cos beta b bar minus cos alpha c bar, and this is given to us as half times of b bar, right? Yeah. Now when you compare these two sides, you get cos of beta equals to half and cos of alpha equals to 0, right? So beta value, sorry, now cos beta is equals to, beta equals to 60 degree, alpha equals to 90 degree, right? So now the mod of alpha minus beta is equals to 90 minus 60, this will come out to be 30 degree. Concept test. Let's do this question and then we will end the session. Okay. Uh, okay. I'll try to explain slowly. I just saw the message. So actually, this is vector chapter. है ना? This is vectors, and this is session 2. So, students, you can watch the video also. What I'll suggest is, see, in vector, first of all, there are two things to remember. First is like remember formula, and remember property. So if you do these two things, the question will become very easy for you guys to understand, right? If you remember these two things, the question will become very easy. Any question is solvable. Okay, so the trick to the vector is remembering the formula and remembering the property, and direct application of the properties are generally asked in the questions. Okay, so let's try to solve this question. See, a bar, b bar, and c bar is given to us. For we have to find a bar cross b bar and cross c bar, and then this thing, right? So what I will suggest to you is, first, see, I told you to remember this, right? A bar cross b bar cross c bar, right? We have to remember this thing. So for this we knew the formula. It is a bar dot c bar into b bar, so b bar is multiplied, right? Minus a bar dot b bar into c bar, right? So what I can do here, see, a bar dot c bar, a bar and c bar is given. What is the dot product? 2 into 1, 2 plus 3 into 2, right? So this will be 2 plus 3 into 2, 6, and minus 2 over here, hai na? Into b bar minus, and b bar is given to us as I cap minus j cap minus 2k cap, right? So this is b bar. I substituted this. I did the dot product of a bar and c bar. Now I am doing the dot product of a bar and b bar. A bar and b bar dot product will be 2 into 1 2 2 minus 3 into 1 minus 3, then minus 1 into minus 2 plus 2, right? And c bar is given as I cap plus 2 j cap plus 2 k cap. What will this come out to be? 2 plus 6 8, 8 minus 2 6, 6 times of this thing. So 6 I cap minus 6 j cap minus 12 k cap, right? Minus 2 plus 2 4 minus 3 is 1. This will be I cap plus 2 j cap plus 2 k cap, right? So this will result in the net vector 6 I cap minus I cap 5 I cap, 6 j cap minus 6 j cap and minus 2 j cap. This will be minus 8 j cap minus 12 k cap minus 14 k cap, right? So we found out the first this thing, right? To find out this thing, I will give you a hint and you can note it down as your homework. So see, a bar cross b bar cross c bar, right? So you know the formula for this thing, right? I told you to remember the formula for this thing, which is this particular here given, right? So for to find out this thing, you change this particular question into this format. How? See, cross product of two vectors can be changed with a minus sign and the vectors can be reversed, right? Now just compare this thing to this particular thing formula, so you will find the answer. Okay, so we will study the application of vector in geometry later in the other class. Thank you guys. Have a good day. From next class it will be slow. Okay, whoever asked this. Come for revision class. Okay, revision class for vectors. I will explain each concept slowly. Okay guys, I'll be leaving now. Have a good day. Bye bye.